Alright, so now we are on worksheet 3.2, and the first few questions ask us to determine if it is a polynomial function, and if so, to state the degree. Now the degree is always named by the biggest exponent, so if this is a polynomial function, we would have a degree of 2. Now, it is a polynomial function because nothing is 0 and nothing is a fraction. If we put this in, it would give us a parabola. So this one is a polynomial function of degree 2. Now this one has fractions. With these fractions, this changes it. This is no longer a polynomial of degree 2. This one would not be a polynomial. Okay. This number 17 also would not be a polynomial because this exponent is a fraction. Okay? It can't be a polynomial function if this has a fraction in it. Alright. On the next section, it asks us to determine what transformations occurred from the parent functions and to sketch the graph. So remember, anytime it's inside the parentheses, it's going to affect left, right, and horizontal changes. Anytime it's outside parentheses, it's going to affect your vertical stuff. Is it going to shift up? Is it going to shift down? Is it going to vertically stretch, vertically compress? Now, this doesn't have anything in front of the x, so it's not going to stretch or compress. This one is inside the parentheses, so anytime it's inside the parentheses, it's the opposite of what you think. So since it says +1, we would think, oh, we're moving to the right one. But really, we're moving left 1. So when we draw this, we move over this way. And this one is kind of funky. It looks kind of like a W because of the power of 4. Okay. Now, this x to the 5th looks kind of something like a cube graph that we've talked about before. This 3 is on the outside, and it's making it go up or down. It's outside, so it's what we think. So this is going to go down 3. So we would take our 5th root function, which is going to look something like this. Okay. Hold on, let me check one thing real quick. Yeah. Okay. So, now, here we have two things. We have this -1 on the inside. This is going to be horizontal. It's the opposite of what we think because we're in parentheses. So this one's going to take us right 1. Okay? And this +2 is outside, so it's going to be exactly what we think. So this one's going to move it up 2. So instead of being like this, okay, we're now going to be right 1 and up 2, so it's going to be something like this. Okay, and last but not least, we have another one with a 4th exponent. Again, it's outside, so it's going to affect our vertical. It's bigger than 1, so this is going to be a vertical stretch. Okay, this 1 is inside parentheses, so it's going to be the opposite of what we think. So since we're adding 1, this is going to shift us left 1. And this one is outside, so again, it's going to do what we think. It says +1, so we're going to go up 1. So with our little W-shaped graph, we're going to stretch it, and we're going to move it. Oops, sorry, I realized I put this one to the wrong way. This needs to shift over this way. So it should be something like this. Not this. Okay, so we're going to go left 1. Okay, like we did up here. And then we're also going to make it stretched up more. And we're going to shift it up 1. So it's not going to be on the axis anymore. So it's going to be like this, where everything's more spread out. So that's how we do that part of our worksheet 3.2. For the next page of 3.2, or this starts at the bottom actually, number 37, it says form a polynomial whose zeros and degree are given. So remember, degree is going to tell us our exponent, So we would end with an exponent of 3, okay? And the zeros, remember, anytime that we're solving an equation, our zeros are where we touch the x-axis. So we're going to touch the x-axis at -1, at +1, and 3. So going back to Algebra 1 and back to Algebra 2, anytime we knew that these were our solutions, this meant that we started with the opposite inside the parentheses. So this one tells me x plus 1. This one tells me that we're going to do x minus 1. And this one's going to tell me we're going to do x minus 3. And that this would create my function. And the reason being that these are my zeros is if we had x plus 1 instead of equal to 0, when we subtract, x would equal -1. That's what this represents. Okay, now it wants us to put it back together so that we show that we got a degree of 3. So you're going to FOIL a couple of times. So I'm going to FOIL this first one together first. So x times x is x squared, x times -1 is -x, 1 times x is a positive x, and 1 times 1 is a -1. Now, to make our life simpler, we're going to simplify inside this parenthesis. Since we have the negative and the positive, these are going to cancel each other out. We still have this x minus 3 that we have to FOIL. So now we have x squared minus 1 times x minus 3. So when we FOIL this, x squared times x gives us x cubed. Well, that's what we wanted to make sure we had, so we got that. We have x squared times -3, which gives us -3x squared. We have -1 times x, which gives us -x, and -1 times -3, which gives us a +3. None of these are like terms, so this is my polynomial function. Okay, so let's try one more of those together. Number 43. We have a 0 of -1 with a multiplicity of 1. That means that parenthesis is going to happen one time. We're still trying to go for a degree of 3, so that means when we FOIL it back together, we need something that has a cubed in it. So this one, we're going to have 1x plus 1, because remember, the zeros are the opposite when we put them back in the parentheses. And then this 3 has a multiplicity of 2. So we're going to have 2 parentheses that are x minus 3. And then we're going to do the same thing we did on the last one, where we FOIL them together. So x squared times x squared, x times x gives us x squared, x times -3, -3x, 1 times x, x, and 1 times -3, -3. Okay, we still have this other x minus 3 sitting out here, but we need to simplify this first to help us out. So when we put these together, we're going to get x squared minus 2x minus 3 times x minus 3. And I like to think of this a little bit more like regular distribution, where I take each of these and multiply it to all 3 of these. So I'm going to take the x and take it to each of these. So x times x squared is where we're going to get our x cubed. X times -2x is going to be -2x squared. X times -3 is going to be -3x. And then we're going to come in and we're going to do the same thing, but we have to multiply everything by this -3. So -3 times x squared is -3x squared. -3 times -2x is a +6x. And -3 times -3 is going to give us a +9. Now, we have 2x squared and we have 2 x's, so we got to put those together. So we're going to end up with f of x equals x cubed is by itself. -2 minus 3 is -5x squared. -3x, +6x is going to give us a +3x, and then +9 is by itself, because again, it didn't have a partner. And there's nothing left that can be combined, so this is our answer. Okay, so for this next section on your worksheet, it wants us to do multiple things. So the first thing it wants us to do is to find the zeros. So it's already factored for us. We have to decide what values it gives us. So we're going to set each thing equal to 0. 3 cannot equal 0, so this isn't going to give us anything. X minus 7 can equal 0 if we get that x would then equal 7. Okay? And x plus 3 can equal 0 if we subtract the 3 over, that tells us x equals -3. Okay, so that's the first thing. It wanted to know the zeros. So one of my zeros is 7, and one of them is -3. The next thing it asks us for is to determine whether the graph crosses or touches the x-axis and to determine the multiplicity. So see how the exponent here is 1? So this x equals 7 is going to have a multiplicity of 1. And see how this one's squared? This is going to have a multiplicity of 2. Okay. Now, if it's an even number multiplicity, it's going to touch the x-axis. If it's an odd number multiplicity, it's going to actually cross the x-axis. So this one is actually going to cross the x-axis. Okay? Whereas this one, because it's even, is only going to touch the x-axis. And then the last thing it asks us to do is to determine what type of function it's going to most resemble if we FOILed it back together. So since this is a squared and this is a singleton, we're going to end up, with an x cubed. So this is going to resemble an x cubed. Okay, so let's try one more of these, and then that'll be the main concepts from this worksheet. Okay. So, again, we're going to set each piece equal to 0 to find our zeros. So x minus 5 will equal 0 if x is 5. Okay? Now, that's one of my zeros. Because of this exponent, this tells me it's going to have a multiplicity of 3. So it has a multiplicity of 3. That means 3 of my zeros will be equal to 5. Since this is an odd number, that means it's going to actually cross the x-axis here at 5. Okay? Now over here, x plus 4 is going to give us a solution when x equals negative 4. So that is my second zero. Now this one, because its exponent is 2, has a multiplicity of 2. Because it has a multiplicity of 2, it's an even number, it's going to just touch the x-axis and not actually cross there. So this, to help you with this next section, this would be resembles an x to the 5th, because we have x cubed times x squared. When you add those together, that gives you x to the 5th. So if I was drawing this at positive 5, okay, we would have 1, 0, and at negative 4, we would have another one. So that means here, it's actually going to cross the x-axis, okay, but here, it's going to touch it. So it's going to do something like this. So it actually crosses here at at positive 5 because it has a multiplicity of 3. Whereas here, it's just going to touch the x-axis and bounce back down because it has a multiplicity of 2, which is an even number, so it just touches.